A common thing we want to do when we're dealing with probability is to find a conditional probability. So let's examine this. We have a database of 100 emails. 60% of those emails are spam. 40% of the emails aren't spam. And of those emails that are spam, 80% of them have the word buy. 10% of those emails that aren't spam have the word buy. What is the probability that an email is spam if it has the word buy? Okay, so in this situation, if we denote S as an email having spam, then what we're looking for is the probability that an email is spam if it has the word buy. So if it has the word buy is another way of saying given that it has the word buy. So out of all the emails that have the word buy in it, how many are actually spam? The probability that we're given up here is that 60% are spam. So the probability that an email is spam is 60%. The probability that an email is not spam is 40%. Now this 80% applies only to those emails that are spam. So 80% of the emails that are spam have the word buy. This is another way of saying that the probability that the email has the word buy in it, given that it's spam, is equal to the 80%. And down here, the probability that it has the word buy in it, given that it's not spam, is 10%. So there are very few emails that have the word buy in it that are not spam. So you can be probably pretty confident that if it has the word buy in it, then it is likely going to be spam. But what we want to know is what out of all the emails that we get that have the word buy in it, what's the probability that it's spam? Notice that the conditional probabilities we have here have the condition and the event reversed in terms of what it is that we're looking for. So let's go ahead and construct a table. A lot of times constructing a table is a much easier way of solving these problems. So here we're just going to put along either our rows or columns. Let's just say this has the word buy, does not have the word buy, is spam, is not spam. So we know that 60% of those emails are spam. So that's going to be down here, 60%. So I'm just going to put 60 just so that we're working with number of emails. And then that means immediately that 40% of those emails are not spam. And since we have 100 emails, we could put 100 over here. So these add up to 100 as well. Now we don't know what percentage of emails have buy in it, and we don't know what percentage of emails do not have buy in it. But we know that of all the emails that are spam, out of all 60 of these, we know that 80% have the word buy in it. So of these 60, 80% of those have the word spam in it. So that's 8 times 6, that's going to be 48, or 48%. Okay, so that's the 48 that go here. Now notice that the way we obtain that number is by taking the probability of S, well, at least the whole number variant of it, and multiplying it by the probability of B given S. So we've just constructed an AND probability by taking the probability of B given S and multiplying it by the probability of S. And that gave us the probability of B and S. And that was the 48. I've reversed these just to make it look like we were looking at all spam emails and then multiplying it by the likelihood that a spam email has the word buy in it. Now we could also do the same thing for this cell over here. We know that 10% of those emails that aren't spam, that is 10% of the 40, have the word buy in it. So if I take 10% of 40, then I'm going to get 4. And that 4 is the number of emails that have the word buy in it and are not spam. And so again, what we did here to find the probability of B and not S is we took here, I'm gonna again switch these. This is the probability of B given not S, all right, B given not S, multiplied by the probability of not S. And that was the 40, and this was the 10%, and that gave us this 4. Now at this point we have enough to fill in all the blanks. So if 48 of all the spam emails have the word buy in it, that means 12 do not, so that they sum to 60. And I'm just going to use a different color here, 12. And since 40 emails are not spam, but 4 of those do have the word buy in it, that means 36 do not have the word buy in it. At this point, we can fill in the rest of the table. We know that 48 plus 4, that's 52, which gives us all the emails that have the word buy in it. And we could add 12 and 36 here, that gives us 48. And nicely, like this beautiful puzzle, 52 plus 48 should sum to 100. And if we add up all these values, they should add up to 100 as well. Now we have enough information now to be able to construct the percentage of all emails that have the word buy in it. How many of them are spam? Well, we know that that's going to be the probability or the percentage of emails that are both spam and have the word buy in it, divided by, now our condition, we're only looking at the emails that have the word buy in it, which is this 52. So that's going to be the probability of event B. Now, I know these aren't probabilities, but if we just move the decimal place over to the left too, then we do have them. So this number here is going to be the 48, or we could put 0.48 to be more mathematically precise in terms of what a probability is. And that's going to be out of all the emails that have the word buy in it, which is the 52. So we divide that by 52 or 0.52, and we come up with about 0.92. So if we know an email has the word buy in it, then we can be 92% sure that that email is actually spam. And in the next video, we'll go ahead and try to generalize what we have here in the table by looking at the actual symbols that we use to construct this.